Hello everyone, welcome back to my channel. Today we are going to learn about a very interesting topic which is called indices. So let's understand first what do we call as indices. So basically when we write something like 5 raised to power 3, this is what we pronounce it, 5 raised to the power 3, or 3 is the power of 5. Yeah, 3 to the power of 5, right? So here the two things are there. One thing is this small thing, this 5 thing is called base. This thing, the power, is called power, or we call it exponent, or we call it index. Index basically stands for the power of the given base. Okay, so let's understand in a deeper way how these powers work here. So let's try an example. Suppose if I'm writing something like this, 9 raised to the power 3 or 2 maybe, right? So which exactly means that I'm talking about 9 which is occurring 2 times, right? So it's not 2 times 9, it's 9 times 9, right? Index basically means the number is repeating itself. Okay, so this gives you an answer as 81. All right, then if I'm taking any other example, suppose I'm writing 2 raised to the power 5, right? So that means the number 2 is repeated 5 times. Okay, that means I'm going to open this up like this, and 2 times 2 is 4, 4 to 8, 8 to 16, 16 to 32. So that's your final solution for this, right? So this is all about the index thing, right? So whatever is there in the index, you are going to repeat that number that many times, right? Next thing is when we talk about the positive and the negative powers. So let's draw a line in between. So we'll talk about positive powers, or we can call indices, and negative powers. So you need to understand one thing which is called even and odd, right? So positive stands for the even cases. Here, anywhere you see positive, you get a positive answer when you have the even power in the on the base. Okay, and when you see a negative power, so that means you're going to have a odd number in that. Odd number means odd numbers are basically 1, 3, 5, 7, and so on. Even numbers are 2, 4, 6, 8, and so on, right? So let me take an example to make you understand it little more. If I'm writing the above two examples which I gave you is also the positive power examples, right? If I'm writing 3 raised to power 4, okay, so it's 3 times 3 times 3 times 3, right? Because the power is even number, right? I'm talking about the powers here, so power is even, right? That means whatever answer you're getting is going to be a positive solution. Okay, but if my question is like this, minus 3 raised to power 4, right? Your base here is negative 3. Okay, for negative powers, when you see a negative number in the question and the power becomes positive, I mean not positive, I mean it becomes even, then your answer is going to be, this means that minus 3 is repeated 4 times like this. Okay, and the final solution is 3 times 3, 9, 9, 9, 81. Okay, but it should be a positive one. Reason being, because the power is occurring 4 times. So the negative number is occurring even number of times. That means it makes it positive, because negative negative got positive, then positive positive got positive. Okay, so that's why both the solutions are same, like this. And there could be one more case if I'm writing minus and 3 to the power 4. So what is the possibility here? So I am going to repeat the same thing, but whatever answer you already got for the above one is this, right? So I am putting a negative sign, which is this one, and 81 as a solution. Okay, so you need to understand where your negative power is lying, whether it is inside or outside. So you need to focus more on that. Okay, so let's take some examples for the odd powers as well. Suppose if I'm taking 2 to the power negative 5. No, not negative power here. It should be in the base. Okay, so if I'm taking it like this, that means minus 2 is occurring 5 times, right? And as I told you that whenever you see an odd power, then your answer is going to be negative. So 2 times 5 is going to give you 32, but it should be a negative one here, like this. So I hope you understand what exactly the even and the odd powers make here. Okay. Next concept is laws of indices. This is very important. This is going to work out with you till all the grades. You are going to use this thing everywhere, whether it could be surds, radicals, whatever, algebraic, complex theory, whatever you will learn in future, this is going to help you out. So please try and understand it little more. Right, so I'm taking one by one all the laws along with the examples right now. So the first law says that when the bases are same and the powers are different with a multiplication sign in between, then we are going to add these powers like this. Okay, I'm repeating my law. I'm saying when the bases are same and the powers are different and they are separated with a multiplication sign, right? So then the powers got added. Okay, so let's take few examples. If I'm writing 2 to the power 5 times 2 to the power 9, so that makes it 2 to the power, sorry, that makes it 2 to the power 5 plus 9, which makes it 2 to the power 14. See, if the powers are more than 5, then you're not supposed to solve it. If you're using your calculator, then it is up to you if you want to solve this power thing or not. Okay, that is not going to be necessary otherwise. If I'm writing something in fraction, if it is 1 over 5 to the power 3 times 1 over 5 to the power negative 2. Okay, here I'm not saying that the indices are going to change anything, but the bases are same. So I'm just using my law. So it is 1 over 5 to the power 3 plus negative 2, right? Because here the indices are 3 and negative 2, right? So according to the law, I'm using it with a addition sign, right? So that means my answer is 1 over 5 to the power 3 minus 2, right? That makes it 1 over 5 to the power 1. So 1 is basically single power, so we don't need to show it in the brackets, right? You can open it up and leave your answer here. Okay, let's take another law. Next law says when we have a to the power m, I mean the bases are again same and there is a difference in that with a division sign, or they are written in this format: a to the power m over a to the power n. That means we are going to subtract the power. Okay, let's take few examples to understand it better. If I'm writing 2 to the power 9 divided by 2 to the power 8, okay, so that is very straightforward, which is 2 to the power 9 minus 8, which gives you 2 to the power 1, which is exactly equal to 2. Okay, let's take one more example. If I'm writing 2 over 3 to the power 15 divided by 2 over 3 to the power negative 19. Okay, then we are going to solve it. So it's 2 over 3 to the power 15 negative 19. Okay, because the here the indices are 15 and negative 19, right? So basically 15 and negative 19 are not going to change their sign, but I am introducing one more extra minus sign because of the law. Okay, so that means my answer is going to be 2 over 3. This is going to be 15 plus 19, right? So 2 over 3, 15 plus 19 is 34. So that's your answer here. I hope you understand this law as well. These are not going to be very complicated. These are very simple, but they can come with the complex forms. Okay, so let's learn the basics first, and then we'll jump on to some difficult style questions. So the third rule is very important. This occurs many times. Even if you don't know it, you just recognize it now. A to the power m and n. Suppose if two powers or indices are there on a single base, then we are going to multiply these powers. Okay, so let's take an example again. If I'm writing 1 over 7 to the power 2, and after that one more power is negative 3. Okay, so I'm writing 1 over 7 to the whole power 2 times negative 3, right? See, the plus and the minus powers are never going to matter in this case, because we are following certain laws which are based on the in-between signs, right? So that means it is 1 over 7 to the power negative 6, right? You can leave your answer here. I'll later on tell you how to make the positive indices or the negative indices, right? That is going to be, after a few laws, we'll learn about this as well. I hope this is also clear. Fourth rule says when you have a to the power b, a to the power m, and b to the power m. See here that the bases are different this time, but the powers are same, right? So we'll multiply the bases and make a common power here. Okay, so if I want to take an example of this, I can write it 2 to the power 5 times 1 over 32 to the power of 5, right? So I can see that both have 5 power and there is a multiplication sign in between. So I'll multiply 2 times 1 over 32 and make it whole power 5, right? Now you can solve it easily. I can cancel it out, right? So wherever you see the cancellation things, you can also follow the same, right? So this is going to be my answer. Fifth rule says when we see a to the power m and let's take the division sign this time. Division sign b to the power m, right? Or it can be written in a to the power m over b to the power m. Then we can make the same thing. We can make the bases here and write the power in a common form, right? Same thing again happening here. If it is 2 to the power 2 or 3 to the power 2. So that makes it 2 over 3 to the power 2. Okay, if you want to solve it further, as it is below 5, so we can do it. It's 4 over 9. Okay. Sixth law. Sixth law says when you see some negative power in the denominator or in the numerator, right? We are going to reciprocal the number, the base actually. So this is going to be reciprocated here. So it is going to give you 1 over a to the power m. Okay. So let's understand it better. If I'm writing something 2 to the power negative 5, that means if I want to make a positive power here or the positive index here, so I'll be writing it as 1 over 2 to the power 5 or 1 over 32. Okay. If I am writing 1 over 3 to the power negative 2, so that means I have to again reciprocal it to make a positive indices, right? So I'll take the 3 in the numerator. So it's 3 to the power 2 only now, right? If it is in the denominator, then you have to take it to the numerator. If it is in numerator, then you have to take it in the denominator to make the exchange of powers, right? So this is going to give you 9 as a solution. Okay. Then the next one is the last. So if you see any number is having a power 0 or an index 0, that means it is 1. Okay. Sometimes they may give you very different kind of situation, but you can directly write, if you are seeing any number's power is 0, you can seriously straightway write 1 over there. Okay. If I'm writing 5 to the power 0, that means it is 1. If I'm writing 1 plus 2 plus 9 to the power 0, that is also 1. Why we are going to solve it? We are not supposed to solve it because the whole power is saying 0, right? Index of the whole power is 0, right? That means it is making 1. We are not supposed to solve it. If it is 5 plus 1 over 3 plus 2 over 27 to the whole power 0, that is also 1, right? We are not supposed to solve the inside part. We are not supposed to follow any BODMAS rule here. You're simply seeing that the index here is 0. So you're not supposed to take any chance, right? You can leave your answer here, right? Nobody is going to question you in that. This is the full and final answer here, right? I hope you understand today's lesson. I hope it does make some sense to you guys. And I hope to see you guys soon, right? Please follow, like and subscribe my channel for further information relevant to your maths, right? I am here to make this maths as your favorite subject. Till then, goodbye. Take care.